Today we'll be talking about equivalent fractions, but before I begin, let me just remind you of what we did last time. So we had two interpretations of fractions. So here's the interpretation, um, which is going to be 7 divided by 3. So according to the division interpretation, this is equal to 7 over 3. So these two things on the right hand side and the left hand side of the equality mean the same thing. But now what we can do is we can also think of it as that we take a unit interval, and this is what we did last time. We took a unit interval. This is the part of a whole interpretation, and we take these unit intervals 0, 1, 2, 3, and we break them up into three equal parts because we can go on, so it doesn't have to stop at 3. It goes on, so this goes on to 4, and then dot dot dot, it goes on forever. Okay, and then we break it up because it is over 3, so we're looking at thirds. So we break it up into, each interval is broken up into thirds. We break up each interval into thirds, and then what we do is we're going to pick out 7 of those parts. So this is going to be the first part, the second part, the third part, the fourth third, the fifth third, the sixth third, and the seventh third. So this number right over here will be 7 over 3, and this we can write also as um, 2 wholes plus 1/3, because it's 2 wholes plus a third, which can be written compactly as 2 whole 1/3, and this is called the improper fraction. So this is improper fraction. So this is representing one number as an improper fraction, and this is writing the same thing as a mixed number. Okay, so this is what we essentially learned last time. Okay, so today what we're going to do is we're going to talk about equivalent fractions. So the first thing that you need to know is what do I mean by equivalent fractions? Fundamentally, equivalent fractions are essentially a way of giving different names to the same number. So it's equivalent fractions. If you think of as we'll go about doing it, this is an important thing. Equivalent fractions is really the idea. So this idea is really that you have the same number but different names. So it's the same number, different names. Okay, so what do I mean by that? Different name. So what do I mean by that? What I mean by that is, let's think about a number like 3 over 5. So here's a number 3 over 5, and I'm going to I'm going to use part of a whole interpretation here. So here's 3 over 5. So I'm going to have 5 equal pieces. So 1, 2, 3, 4, and 5. So these are 5 equal pieces. And now what I'm going to do is that I want to take 3 out of those 5 pieces. Let me take 3 out of those 5 pieces. So I have 3 out of those. This is 3 over 5. Okay, and so this is 3 over 5. Now what I can do is I can break up each piece into 2 equal pieces. So let me do that. So I'm going to take a green piece and break it up into 2 pieces. Each one of the pieces is being broken up into 2 pieces. Now remember, this was the first piece, this was the second piece, this was the third piece, the fourth piece, and the fifth piece. So the 5 pieces have now been, each one of the 5 pieces has been broken up into 2 pieces. So that means how many pieces are there? Well, now there are really 10 pieces, right? The red pieces are now 10, if you think about it, because each one of the 5 pieces has been broken up into 2 pieces. So I can say that this is really equal to, because each one of the 5 pieces got broken up, so these are 2 5s. that I have, right? And now remember, since I broke up, so I had three chocolate pieces, but three chocolate pieces also got broken down into two pieces. So this was the piece I had, and now I have, instead of one large green piece, I have two small red pieces, and the same applies to this one, and the same applies to this one. So that means I really have two threes, right? So what that means is that 3 over 5, or 3 fifths, is the same as 6 tenths. And they are the name of the same number on the number line. That's an important idea. So if you have a number line, here you have a number line. So if I have the number line, here's 0, here's 1. I'm going to break it up into 5, 2, 3, 4, a bit longer than I thought, so let me make it a bit smaller. So here's our number line, and this is 1. Okay, so 3 fifths. So this number right here is 3 over 5, and this number right over here, this number right over here, this is this number. This number also has the name 6 over 10. It's just like you having two names. So you have a formal name, and then you may have a nickname at home, but you're the same person. Similarly, this number, and by the number I mean this thing right over here on the number line, which is 3 over 5, has a different name, which is 6 over 10. Okay? Um, Similarly, we can do other things, like maybe have another number like 2 over 6. So here's 2 over 6, so which means I need to have a chocolate bar, and I'm going to have 6 pieces. Again, I'm using part of a whole. I'm going to have 6 pieces: 1, 2, 3, 4, 5, 6. So I have 6 pieces out of that, from the chocolate bar. And if I write 2 out of 6, what I mean by 2 out of 6 is that I would like to have 2 out of those 6 chocolate pieces. So here's maybe one chocolate piece, and here's another chocolate piece. So this is 2 out of 6, right? But what I can do is I can now um, divide these 6 small chocolate pieces into 3 big pieces. So this is would become one piece. Here's another piece, and here's another piece, right? There are 3 big chocolate pieces, and I have 1 out of those 3 chocolate pieces. So what that really means is that I took the 6 pieces and I divided it by 2, and now since each one of the pieces is twice as large, so that means my 2 pieces actually become one piece. Okay, so this is a big idea, that you can take a fraction, and multiply the denominator and the numerator by the same number, as we did over here. So we multiplied the denominator and the numerator by 2, that is one thing, by the same number, or we could divide the denominator and the numerator by the same number. The important thing to remember is that you have to use the same number for the denominator and the numerator. Okay, so let's think about another problem, like maybe, so let's think about it like a number like 3 over 4. Well, I can take the number, and now I can break up the denominator into each one of the 4 pieces into 6 pieces, which means the 3/4, the 3 pieces that I have, will also get broken up into, each one of those 3 pieces will also get broken up into 6 smaller pieces, which means that I'll have a total of 18 small pieces out of 24 small pieces, right? But note, I could also write 3 over 4. I could choose to break it down into a different way. I could take my 4 big pieces and breaking them up into 5 small pieces. So now I'll have 5 fours. Well, then each one of my three pieces, since I broke up each one of my three pieces into five pieces, that means I'll have 5 times 3 small pieces. So this turns out to be equal to 15 over 24. So now, if you look at the 2, you can clearly see that um, 18 over 24 is equal to, sorry, 18 over 20. I made a mistake in the multiplication. That was kind of silly. 18 over 20, 5 fours are 20. So 5 fours are 20 and not 24. So 18 over 24 is the same as uh, 15 over 20, right? And the reason why this is true is because 3/4 is the same as 3/4, and 3/4 is also equal to 18 over 24, which is also equal to 15 over 20. Okay, so these two fractions, while they may look different, these two fractions right over here, 18 over 24 and 15 over 20, may look different but are actually the same. And the way you see them to be the same is if you divide the left hand side, the numerator and the denominator, by 6, and the right hand side, the numerator and the denominator, by 5, you'll see that both these um, fractions are the same, and this is the idea of equivalent fractions. So I would go ahead and practice a few problems on equivalent fractions so that you become clear about this idea. Thank you.